Hello everyone, this is our 47th video tutorial under the GCSE topic revision guide called Velocity Time Graphs. This topic, you may study this in the physics, but there is a possibility this question can come up in the maths paper 1 or paper 2. So you can study this tutorial with me, and this will help you to do the physics question as well as maths question. There is a theory behind the physics theory behind the topic, but I am going to do the questions, and at the questions time I'm going to be helping you to explain the theory behind the topic. Let's look at the questions. Hi, this is the tutorial we are going to discuss in this video session. You can download this tutorial from our website at www.smart-tutors.co.uk/worksheet.php. Under the Year 11 section, you can download the tutorial. The annual membership is £24, which works out £2 per month, allows you to download the tutorial in PDF format. Let's look at the exam style question. Question number 1. The speed time graph below describes a 50-second car journey. Work out the total distance traveled by the car and work out the maximum acceleration of the car during the 50 seconds. Right? So speed time graph or velocity time graph, the distance is going to be calculated by the area under the graph. So I'm going to be divide this one in several shapes. So let's look at this as a triangle and a rectangle, and this is going to be a trapezium, and the next one is the triangle again. So I'm going to put this as a. So let me take this rule out. So A, and this is my B, this is C, this is D, right? So area under the speed time or velocity time graph gives the distance. So area of A, equals half times base is 10 times height is 15, which is going to be 2 goes into 1 and 2 goes into 5 is 75 meters. So area of B is 10 to 20 is 10 times 15 is 150 meters. Area of C, it's a trapezium. Trapezium's parallel sides are 15 and 25. So 15 plus 25 divide by 2 times by the height is with this one. This is 10 is the height. So that we need to work it out. 25 plus 30, 40 divided by 2 is 20 times 10, which is 200 meters. Finally, area of D is half base is 30 to 50 is 20 times height is 25. So 2 goes into 10 times 25, which is 250 meters. So these are the answers for the each individual area. So total area or total distance, so total distance traveled equal, so you add 75 plus 150 225 plus another 200, that is 425, another 250, 425, 625, 675 meters. So let me check it again. 5, 5, 10, 17, 1, 2, 4, 6. 675 meters is the answer for the first part. Second part, they asking for maximum acceleration of the car. So the acceleration is speed divided by time. So change in speed, time taken. So if I find out the acceleration, so I put acceleration A between 0 to 10, the acceleration is going to be change in speed 15 take away 0, so 15 take away 0 divide by the 10, so 15 divided by 10 is 1.5 meter per second squared. Acceleration between 20 to 30, so which is here 25 take away 15, so 25 take away 15 and divide by 10, and 25 divide by 15 is 10, 10 divide by 10 is 1 meter per second squared. So the maximum acceleration car is what? 1.5. so acceleration, so maximum acceleration, so maximum acceleration during 0 to 10 seconds is 1.5 meter per second squared. That is our answer for the question number 1. Question number 2. Here is a speed time graph for a car. First question, work out an estimate for the distance the car traveled in the first 6 seconds. So first 6 seconds means up to here. So we need to find out the area under this curve. So I'm going to be making a stripes for 4 to 6. So 4 to 6 is a trapezium. So I'm going to connecting this to this. And I'm going to be connecting 0 to 4 as a triangle. So 2 stripes, so I'm going to not making 3 stripes, so A and B. Right, more you divide stripes is more accuracy, but I don't have time to do that one, so just to quickly work it out. So area of the A is half times base is 4 and height is 5. So 5 is the height, is 10 meters. Area of B is trapezium, the height is 5 and this one is going to be 2 boxes is 1, so 2 boxes drop, also 9. So 5 plus 9 divide by 2 times by 4 to 6 is 2, so times by 2. 2 and 2 cancel, so 9 plus 5 is 14 meters. So the total distance, is 14 meters. B part, is your answer to an underestimate or an overestimate of the actual distance? So our answers is the above the curve, so it's an overestimate, so it's an overestimate. Give a reason for your answer. So if you see this graph, our calculation is the triangle construction, the line, straight line above the curve. So we are adding the extra area in our calculation. So actual area is below that. So our calculation based on triangle and trapezium, the line above the graph gives additional area. Therefore it's an over estimate. Right, so that is the answer for the B part. C part, calculate an estimate for the gradient of the graph when t equal 8 seconds. You must show all your working. So this is the let me change to red color. So t equal 8 means you need to draw a line, a straight line using a ruler, so until it cuts the graph somewhere there. Now we need to construct a right angle triangle, a tangent at 8. So tangent to the curve somewhere like that. So you need to draw a tangent to the curve. So not like that. So if I draw that again. Right. So and you need to complete the right angle triangle. That is perfect right angle triangle. Right, and now you need to find out what is the distance actually, right? So this is 3 boxes here, and this is 10 boxes here, this is 10 boxes here, and another 10 boxes, and 1 2 3 4 boxes here. So 4 plus 3 is 7 boxes here. So altogether 27 boxes there, right? So 2 boxes is 1, so 27 boxes is 13.5. Right, and this one is going to be 6 to 8 is 0.2 actually. So here 8 and here 10, so 2 spaces. And this one is 9, so that means 1 divided by 5 is 0.2. so 0.2 means here is 1 boxes less, so that means altogether is going to be 2 plus 2 4 take away 0.2 is 3.8. so you need to find out the length of this one. So the gradient is, so gradient is 13.5 divided by 3.8. So 13.5 means 5, 10, 13.5, 3.8. So we need to use a calculator. So 13.5 divided by 3.8. So the answer is 3.55. So 3.55. So 3.55, and the unit for this one is meter per second divided by second, so meter per second squared. Right. So that is the answer for the question number C. Describe fully what your answer to part C represent. It represent acceleration. It represent the acceleration at t equal 8. That is the answer for question number 2. Question number 3. A parachute jumps out of a plane. This graph shows information about the velocity v of the parachute t seconds after he jumped. Work out an estimate for the acceleration of the parachute when t equal 8. Right, so when t equal 8 means, so from here t equal 8 is somewhere here, and you need to draw a right angle triangle or tangent on that. So I'm not accurately going to do this one, so because I don't have a proper tools here. So that is the, so possibly and I'm going to draw the right angle like that and like that. So basically where they're asking for the gradient or acceleration at t equal 8, that is the point. At that point you need to draw a tangent. So tangent, the rise over run is going to be divided, and that is the gradient. So we need to find out what is this distance here. 40 to 50, so 10 boxes is 10, so each boxes is 1, so you can count here. So from here to here is a 3, so 7 here, and here to here is 5, so 12. So 12 small boxes, and here 12 is here, and is here 4, and so 2 to 4 is what, 2, so 10, 0.2. so 0.2 means, so 1 2 3, so 8, so 1.6, so 0.2, 0.4, so 12, so 4 to 12 is 8, 8.4. so this distance is 8.4, we already calculated, right? So the acceleration is going to be 12 divided by, so 12 meter per second divided by 8.4. so the answer is, my answer is going to be not going to be the accurate one, so you will get some different answer, but don't worry, in the marking scheme they have a range of answer satisfying your answer. So if it is within the range, you will get the correct answer. So 1.43 I'm going to put, so 1.43 meter second squared. Question number B, work out an estimate for the distance for the parachute falls in the first 6 seconds. So 6 seconds means I'm going to drawing stripes to find out the distance. So this is second stripe, and this is the third stripe. So this is, I'm considering as a triangle, and this is the trapezium, and this is the trapezium, right? And now I'm going to write this as a, this is B, this is C is the answer. So area of A, which is half, base is 2, height is 20, so this is going to be 20. So area of B is trapezium, so 20 plus 35 divided by 2 times by 2. So this is going to be 35, 45, 55, and area of C, which is again a trapezium, so 35 plus this is going to be a 45, yeah, roughly 45, divide by 2 times by 2. They already asked for estimate, so you don't need to be worried about too much. So 50 is 80, so the 80, 55 and 20, so the total area, is 80 plus 55 plus 20, so 155 meters is the distance it traveled within the first 6 seconds. Question number 4. An athlete is running in a race. The diagram shows speed time graph for athlete. Work out an estimate for the acceleration of the athlete at 3 seconds. So same question as what we did before. 3 seconds means, so at 3 seconds you need to draw a gradient line. So this is the 3 seconds. I need to find out which point it's cutting. There is the point. At that point we need to draw a right angle triangle. So right angle triangle means something like that. So not that one, so it's a little bit steeper. So that looks like a right angle triangle, and draw the tangent, and so this is the right angle triangle, and this is the gradient, so you need to calculate the rise over run. So acceleration at time equal 3. So change in velocity divided by time taken. Change in velocity, so this is 14, take away 6, so 14 take away 6 is 8. Then time taken is, this is, looks like this is what, 1. So 1 to this is 5, 5.2, 5.4. So 5.4 take away 1. Sorry, this is 5.4, my the pen. So this is 8 divided by 4.4, and that is the acceleration. Let me open the calculator. So the calculator, 8 divided by 4.4, which is 1.82. So 1.82 meter per second squared. The athlete ran the race in 10 seconds. The area under the graph gives the distance the athletic run in 10 seconds. Show that the race could have been a 100-meter race. So we are going to be finding the area under the curve up to 10 and estimating that is the curve. So we are going to be drawing the constructions line. So here 10, drop a line, so that is there. So here drop a line, that is there. So the area of this one is A. So I'm going to put this as a A. And next one, I'm going to draw another construction line is 4, and another construction line as 2. And now we are going to draw the straight line. So this is triangle, and this is a trapezium, and this is a trapezium, and this is a rectangle, right? This is A, this is B, this is C, and this is D. So area of A is a rectangle, which is 6 to 10 is 4, and the height is 12, so it's easy, 48 meters. Area of B is a trapezium, so half, this is 12 plus this is going to be this is going to be 10 to 12 is 2 within the 1, 2, 3, 4, 5, 0.4 is 1 boxes, isn't it? So here is 10, 1, 2, 3. So 3 means 1.2. So it's going to be, so here 4, 8, 3. So 3, 11.2. 11, 8. So 1 box, 2 box. It's nearly 2.5 box. So 2.5 box means a 3 box means 2.5 box means 2.5 times what? 0.4, which is 1, and I would say 8 is 11 times it's going to be 2. So it's going to be 2 and 2 cancel, 12 plus 11, 23 meters. Area of C. So area of C half, then this is going to be 11 plus this is 6 and 1, 2, that is 3, definitely 3. So 7.2. 7.2 times 2, and 2 and 2 cancel, so 18.2 2 meters. And the next one is area of D. Area of D is triangle, half, base, and this is 7.2, and that is going to be 7.2 meters. So if I add 48, 23, 18.2 and 7.2, which is going to be 4, 96.4. This is roughly is 100 meters. So we can conclude the athlete run have been, the race has been a 100-meter race. So understand the technique behind this topic is the distance can be calculated by constructing lines and finding an area under the curve, right? So that is the question number 4. And question number 5. So question number 5, the graph shows the velocity v meter per seconds of a rocket at t seconds. Find an estimate for the rate of change of velocity at t equal to. So rate of change of velocity at t equal to means, so here t equal to. So that is the point we are going to be constructing the gradient lines. So not sure this is correct or not. It's not. So one more try. I think this will be nice. So that is the gradient line. You can construct the triangle as big as you can. It doesn't matter as long as you draw the tangent. That's more than enough. Right now this is 0 and this is 30 and it's going to be 34, I think, if I'm not mistaken, 34. And this one is 4 and starting from 1 point, what is that, 1.3. So 4 take away 1.3 is 2.7. So acceleration at t equal to is 34 divided by 2.7, which is, bring the calculator, so 34 divided by 2.7, which is 12.6. So 12.6 meter second squared, or meter per second squared. Find an estimate distance traveled by the rocket in 4 seconds. First 4 seconds. So first 4 seconds means, right? So we need to know the boxes here. So first 4 seconds means here to here is the very first one, somewhere here. And here 3 to here. And the 2 here. And the next one is starting somewhere here. And I'm going to draw the triangle. So that's all the triangle area and the 2 trapezium you need to calculate. It's going to be overestimated anyway because our lines are going above the graph. The graph is under the construction line. So the construction line is above means is overestimate. So A, B and C. Let's start with A. So area of A equal half parallel sides. What are the parallel sides? Here to here is 60. I would say 60 to 64. Add 64. Add this is going to be 20, 25 times, and 1 is the thingy. So 989 divided by 2 is 4.5. So 44.5 meter. So area of B. So area of B is half. It's going to be 25 plus this is going to be 10, and it's not going to be that high. And let me do 2 drop. It's going to be 8. So 8 and times by 1. So 33 divided by 2 is 16.5 meters. Area of C is going to be half times base is 1.4 times is going to be 8. So 5.6 meters. So if you add total area, is going to be 44.5 plus 16.5 plus 5.6. So what is the total? So let's take the calculator. So 0, so 44.5 and plus 16.5 plus 5.6, so 66.6 meter is the answer for the question number 5. Now let's look at the theory behind this topic in brief. So before I finish this video session, I would like to summarize what we learned under this velocity versus time graph, which is very good topic. You can apply the theory on your physics paper and the maths paper as well. So just to concentrate this topic now. So O to A journey. So O to A journey is said to be you are speeding up. So change of speed divided by time is acceleration. So O to A journey, it's called acceleration. So acceleration journey is defined by O to A. You are speeding up. So the acceleration is said to be 20 take away 0, 5 take away 0, 20 divided by 5, 4 meter second minus 2. A to B journey is what? Constant speed. So A to B journey is constant speed. So constant speed is A to B. So 20 meter per second. Time is going, so is maintaining the speed constantly. So acceleration is 0. B to C, it's you are slowing down. So you deceleration. So deceleration. So deceleration or deacceleration means you are slowing down. So you're coming to the rest. So the acceleration is 0 minus 20 divided by 10 seconds, which is minus 2 meter second minus 2. So minus indicating is a deacceleration. If you say deacceleration, that is going to be 2 meter per second squared, but acceleration is minus 2. So this is the normal theory. So the gradient gives acceleration. Gradient gives acceleration for the velocity time graph. Now, if you want to find out the distance travel, that is going to be the area of this curve. So the area gives the distance traveled by this particle. So half is a trapezium. Parallel sides, which is parallel side this one, which is 15, and this one is 30. So 15 plus 30 divide by 2 times by height is 20. So 45 times 10 is 450 meters. That is the section you need to understand. So the distance can be found out by the area. Gradient gives the acceleration. Slowing down means deceleration. Horizontal line means constant speed. Other than this, you need to know if it is a curve, if they are asking for acceleration, you need to draw a tangent to that point and make a right angle triangle to find out the rise divided by run gives the acceleration. If it is a curve, and you need to divide the curve into equal stripes to find out the area. Sometimes it can be a underestimate, overestimate answer. You need to justify your answer accordingly. That is the end of our video tutorial. I hope you like our video. If you do like our video, please give us a thumbs up and subscribe to our channel. You can download this tutorial from our website at www.smart-tutors.co.uk. Under the Year 11 section, you can download the tutorial. Yearly membership cost £24, which works out £3 per month, which allows you to download all the tutorials in PDF format and predicted papers and all the past papers. Thank you very much for your time. See you in the next video.